Hello, here we are again for another video. This is performance test number 4. My name is called Joseph Risol, a BSECE3A student. So today's topic is about differential pulse code modulation or DPCM. So pulse code modulation, it is a method that is used to convert an analog signal into digital signal so that a modified signal can be transmitted through the digital communication network. PCM is in binary form, so there will be only two possible states, high and low. So here we are. There's an example diagram on the other side. So what are the three steps of the pulse code modulation? We have sampling, quantization, and decoding. So here, differential pulse code modulation. So it is a technique of analog to digital signal conversion. This technique samples the analog signal and then quantifies the difference between the sampled value and its predicted value, then encodes the signal to form a digital value. Voice or video signal is sampled at a rate slightly higher than requisite rate done in PCM. Found to be highly correlation between adjacent samples, and the adjacent samples of the signal carry the same information with little difference. So here's an example. So a continuing time signal xt denoted by a dotted line. This signal is sampled by flat top sampling at intervals t's, 2t's, 3t's, and n's. The sampling frequency is selected to be higher than the requisite rate. The samples are encoded by using 3-bit 7 levels PCM. The samples are quantized to the nearest digital level as shown by small circles in the above figure. The encoded binary value of each sample is written on the top of the sample. So as we can see here on our waveform also. So the figure at samples taken at 4Ts, 5Ts, and 6Ts are encoded to the same value of 110. This information can be carried out only by one simple value, but three samples are carrying the same information means redundant. The samples at 9Ts and 10Ts, the difference between these samples only due to the last bit and first two bits are redundant since they do not change. So in order to make the process this redundant information and to have a better output, it is intelligent decision to take a predicted sampled value assumed from its previous output and summarize them with the quantized values. So the principle of differential pulse code modulation. So if the redundancy is reduced, then the overall bit rate will decrease and the number of bits required to transmit one sample will also reduce. This type of digital pulse modulation technique is called differential pulse code modulation. The DPCM works on the principle of prediction. The value of the present sample is predicted from the previous samples. The prediction may not be exact, but it is very close to the actual sample value. So differential pulse code modulation transmitter. So we have here a visuals. We have here the sampled input, the comparator, to quantizer to encoder, and we have here the prediction filter also. So differential pulse code modulation transmitter. The sample signal is denoted by X NTS and the predicted signal is indicated by X raised to NTS. The comparator finds out the difference between the actual sample value X NTS and the predicted value X raised to NTS. This is called signal error and it is denoted as ENTS. ENTS is equals to X NTS minus X raised to NTS. The quantized error signal EQNTS is very small and can be encoded by using a small number of bits. So another example is we have here differential code modulation transmitter. Oh, it's the same. The quantizer output would be written as EQNTS and equals to ENTS plus QNTS. QNTS is the quantization error. It can be written now as ENTS plus X raised to NTS is equals to X n times NTS. And we get the XQ NTS is equals to NTS plus X NTS. Thus, the quantization version of signal XQ NTS is the sum of this original sample value and quantized errors Q NTS. The quantized error can be positive or negative. So the inputs for the output of prediction filter does not depend on the characteristics. So we have here the DPCM receiver. So we have DPCM input, encoder, comparator, and output, and we have here a prediction filter. In the absenteeism of noise, the encoded receiver input will be the same as the encoded transmitter output. The predictor undertakes a value based on the previous outputs. The input given to the encoder is processed, and that the output is summed up with the output of the predictor to obtain better output. That means here, first of all, the decoder will construct the quantized form of the original signal. So here we are is the difference, the difference of PCM and DPCM in number of bits. PCM uses for 8 and or 16 bits per sample, while DPCM is lower than PCM bits. Level and step size, PCM fixed step size cannot vary, while DPCM a fixed number of levels are used. And in bit redundancy, PCM is present, while in the DPCM, it's present but can permanently remove. So next is quantization error and distortion. So PCM, it only depends on the number of levels used. So in DPCM, it is loop overload, distortion, and quantization noise are present but very less as compared to PCM. And the bandwidth of transmission of channel PCM, higher bandwidth has been required since the number of bits is absent. So in DPCM, lower than PCM bandwidth. And feedback, PCM has no feedback in TX and RX, while in DPCM, feedback exists. Complexity of notation, PCM is complex and DPCM is simple. In SNR or signal noise to ratio, PCM is good and DPCM is only fair. So application of DPCM, the DPCM technology mainly use speech, image, and audio signal compression. Oh, the DPCM conducted on signals with correlation between successive samples leads to good compression ratios. In images, there are correlation between neighboring pixels. In video signals, the correlation is between the same pixels in consecutive frames and inside frames. So next is we have here our summary now. So PCM stands for pulse code modulation. It is a method that is used to convert an analog signal into a digital signal so that modified analog signal can be transmitted through the digital communication network. DPCM stands for differential pulse code modulation, is a technique of analog to digital signal conversion. Principles of DPCM: if the redundancy is reduced, then the overall bitrate will decrease and the number of bits required to transmit one sample will also reduce. So application of DPCM, it can apply in many ways like image, audio signaling, and medical imaging. So that would be all for today. God bless and thank you.